Mensuration Mobile, quality e-learning experience on the go.
Hello and welcome to our class for today. The topic we are to study today is captioned mensuration for. Okay, and we'll be having particular interest on frustrum of a cone and pyramid. Okay, all right, for us to obtain a frustrum from these two objects, these two solids, we have to carry out some kind of operations on their original volume. Okay, for a frustrum to be obtained from a solid like a cone or a pyramid, the solid must be placed on a horizontal platform, and then where a cut can be made through the solid, okay, but parallel to the horizontal platform, and then we have a frustrum and a smaller cone or a smaller pyramid. Okay, so we illustrate using diagrams. Assuming this is our cone, and then this is our cone, like I said. Okay, right, and then we want to construct a frustrum, so we have to cut the cone at a point here. Okay, I mean, this is where the cutting is made. Cutting is made parallel to the horizontal. Okay, and then with this cutting we have a smaller cone in the form of this. Okay, and then since there is a cutting through, you have another cone altogether. Okay, just trying my best to see if I can get something. All right, so this part is what we call the frustrum of the cone. Okay, and this part we call the smaller cone or the small cone. Okay, so all you're saying in the sense is this is a frustrum and this is a small cone. So these are what we call frustrums. Okay, the same thing can occur in pyramid as well. We can determine the frustrum of a pyramid. The frustrum of a pyramid. All right, so the same thing happens to, assuming we have a pyramid of this form, trying to get something close to a pyramid. Okay, all right, so trying to get the inner parts of the pyramid. Okay, trying to get the inner parts of the pyramid. All right, assuming we cut this pyramid through these sides and this side and this side. All right, so that the line cuts horizontally and then makes the pyramid goes into separate parts, and then we have a new pyramid of this form. Okay, all right, okay, this is a smaller pyramid or the small pyramid. Alright, and then this is our big pyramid. Okay, the one that makes up the foxstrom of the pyramid. Okay, we call this the foxstrom of the pyramid. Okay, this is the foxstrom of the pyramid. All right, so we now have an illustration of what a foxstrom is. So we're going to calculating the surface area and volumes of foxstroms. Calculating the surface, the first surface area and volume of a foxstrom. Okay, you need the following steps we need for this. Number one, you take the foxstrom as a complete cone. Take the foxstrom as a complete cone or pyramid. And then number two, we remove the smaller cone or pyramid. Okay, you can remove the smaller cone or pyramid by subtracting from the original size. With examples you can be able to understand this. Right, let's take example 1 so we could illustrate what we mean by the two steps. Example 1, to calculate the height of the cone, the cone in the diagram below. Okay, alright, the diagram below, and you're given this diagram. Alright, and so we have the height and the base of the pyramid. This is 12 cm. Okay, and then this one is given as the height is given as 6 centimeters, 6 cm. Okay, and the 60 cm is towards the area where you have the curtain go around the pyramid. Alright, and so we need to find out how to compute this. I think this is looking too rough. Make it look better. Should we go over to the next page? Okay, and then this is the point where you have this, and then you're told you have a height of 12 cm. The height too is 12 cm. Alright, so we want to find out what happens to this pyramid. Okay, first of all, if we want to find the height of the cone below, okay, all we have to do is to find the height of the smaller pyramid and then find the height of the bigger pyramids too. You know, from this point, the height of the smaller pyramid is x, and then the height of the bigger pyramid is x plus 2. Okay, these are the things we have to know about this cone. This cone for the smaller pyramid, like we had here for the smaller pyramid, r is equal to 6 centimeters. Small arrow from the smaller pyramid is 6 cm, and big R from the bigger pyramid is 12 cm. Okay, H is equal to X for the smaller pyramid, and big H for the bigger pyramid is 12 cm. You know, these are the same pyramid, but some figures cannot enter, so that's why I make them obvious here, so that at this point we know the smaller pyramid, the smaller cone has a radius of 6 cm. Okay, and then at this point the bigger cone has a radius. Okay, and so back to the next slide. Okay, so how do we go about finding the height? We know that the height of the two pyramids have to be equal for it to be balanced, and so we can say that r is equal to r, and then r is equal to capital H. Okay, which leads us to 6. Small r is 6, big R is 12, is equal to small h is x, and then big H is x plus 12. Okay, when we cross multiply, we have 12x is equal to 6x plus 12. Okay, so that we have that 12x is equal to 6x plus 12 times 6 gives you 72, and so that 12x minus 6x is equal to 72, and so 6x is equal to 72, so that x itself will be equal to 72 over 6, which is equal to 12. So therefore x is equal to 12. Okay, so since we have x to be 12, that means small h is equal to 12, and then big H is equal to 12 plus 12, you know, to be equal to 24 cm. And so here we have the height of the pyramid to be equal to 24 cm. Okay, why we had to do this is because the height of the pyramid inside must be proportional to the height of the smaller pyramid. The height of the first room must be directly proportional. Okay, that is what this line implies. Okay, it must be directly proportional to the height of the small cone. The height of the first room of the cone must be directly proportional to the height of the small cone. Alright, so let's take another example, and I believe with this example you'll be able to understand better. Example 2. Calculate the slant height given the diagram below. Okay, and the diagram we are given here is that of a first room. Okay, this is a first room, we are told to find the slant height. Okay, and from this point we have that right, and then you're told that here is 4 cm, and below is 6 centimeters. Okay, and so the radius itself, the radius here is 6 centimeters, and the radius here is 3 centimeters. Okay, so the slant side we need to find is from this part. Okay, this is the slant side. If you can be able to bring this part out, okay, we have to find the slant side of the pyramid, and that's the slant side. All right, so the height remains the same, 4 cm. Okay, and the slant side, knowing that this part is 3 cm, if you cut it into two, that means this part makes 3 cm and the other side makes 3 cm too, and so here becomes 3 cm. Okay, if it's a straight line going through, then we have 90 degrees here. So how do we find the slant side? We have two sides, and then the hypotenuse, which is the slant side, we don't know, we denote by x, so we can find the slant side, x squared, to be equal to 4 squared plus 3 squared. Okay, good, which is equal to 16 plus 9 x squared, and x squared is equal to 25, and then x is equal to square root of 25. Okay, and then x is equal to 5 centimeters. So this is the value of the slant side. Okay, so this side is 5 centimeters. All right, so we'll go ahead to do one more example, and then we'll round up the class for today. Example 3, talk about calculations of learn how to calculate. This example teaches how to calculate curved surface areas of a forced stream. Okay, given other variables. Okay, the last example taught us how to calculate the slant side. Okay, and that was what we did. And then the first example taught us how to calculate the height. Okay, and now this example 2 will teach us how to calculate to find the curved surface area of a forced stream. Example 3, as I've written above. I hope you don't mind I'm repeating it. Find the curved surface area of the forced stream below. Okay, before we continue, we have to note on the solution side. All right, I've not even given a diagram, and I'm talking of, okay, the diagram follows this way, and okay, all right. cm, and then at this part you have 6 cm too, and then this part you have 4 centimeters. Okay, all right. For our solution, we should note that curved surface areas are determined using the formula curved surface areas are determined using the formula pi RL. And then for this place we have the following. We have the small r for cm, and below we have the big R to be equal to 6 centimeters. Okay, good. These are the two things we look at, where the small r is, and this is where you have the big R, where the cone dissects into two. It's also necessary for you to make the cone look like a complete cone, so that it can ease you in finding the curved surface area. Okay, you can also make it look like a full cone, so that we can be able to find the curved surface area. Okay, here we said it's 6 centimeters, and here we said it's 4 centimeters radius, and then the height from this point is 6 centimeters. Okay, so we have to find the length, because in the formula for the curved surface area, L1 and L2, okay, we have the lengths coming at this point, and so we need to find the length of the first stream. We need to find the length of the first stream. So how do we go about finding L here, like we did previously? Since we have R to be equal to 4 centimeters, and then we have big R to be equal to 6 cm, and then the big edge, the small edge here is equal to X. Okay, let me say it's equal to L, and then the big edge from this point is equal to L2. Sorry, the big edge is equal to, you see 6 and L1, 6 plus L1. Okay, I think that will make it easier. Okay, so and the big edge we're talking about here is L2. The big edge here is L2. Okay, don't mind my method of denoting them. Okay, I can as well denote here to be X. Okay, so that L1 will be equal to X, and then L2 will be equal to 6 plus X. I think this looks better, so that they should be directly proportional to each other, L1, L2, which implies that R1, which is 4, the small r is 6, then L1 X over X plus 6, or 6 plus X, okay, will be equal to 4 into X plus 6, and then 6X, okay, and 6X is equal to 4X plus 24, and then 6X minus 4X is equal to 24. 2X is equal to 24, and then X will be equal to 24 over 2, so that X will be equal to what? Into these two you have 12. So therefore L1 is equal to 12, meanwhile L2 is equal to X plus 6, okay, which is equal to 12 plus 6, 18. Okay, so with this we can be able to find the surface area of the first stream. So the next thing we have to do is to find the height of the cone, okay, to find the slanted height. And so we go about finding the height in this manner. We have that the slanting side L1, L1 is equal to 12, and then L2 is equal to 18. Okay, so we can go back to the first room and then look at the next step, what we'll have to do to determine the rest of the quantities. Now our interest is on finding the surface area of the first room. Okay, and in finding the surface area of the first room, we need the big R, the small r, and the two L's, and then we know that L there is equal to 12 and 18. Alright, so let's go ahead and find the slanting sides of the pyramids. We'll find for the slanting side of the big pyramid and the small pyramid. Okay, so how do we find the slanting sides? Already, you know, we have at this point we have x to be equal to 12 centimeters, and then at this point for the whole of the side we have L2 to be equal to 18 centimeters. Okay, what I'm saying is this: for the small cone we have something like this. We have 12 centimeters, and then we have 4 centimeters. Alright, we have 4 centimeters at this point, and so we need to find this side. Okay, we need to find this side. Alright, so we can find this side. Sorry, I think I used wrong denotations. Let me use a different value here so that it doesn't confuse with the length. Okay, sorry, I hope this won't confuse you. Let me use H to denote this H1 and H2 so that it will make our computations look distinct, because when this L comes into play in this formula it will confuse you. So it's better I denote with something like H. Okay, so that I can denote here as L. Alright, and so trying to find the height of the pyramid being this side. Okay, all we have to do is to use the following. We've obtained that L squared is equal to, because we can solve by Pythagoras, okay, by Pythagoras we have 12 squared plus 4 squared, okay, which is equal to 144 plus 16. Okay, L squared is equal to 160, so that L is equal to square root of 160. Okay, in short form you can write this as 10 root 16, okay, which is equal to 4 root 10. Alright, so for the bigger side of the pyramid being this, okay, you know, we go back to pick the sides. You know, for the bigger pyramid, the side here is 6 cm. You have 6 cm on this part, and then the side here, instead of being 12, because it is 12 plus 6, we have 18 centimeters, and then we'll be looking for L2. Okay, so remember we still use Pythagoras theorem, 18 squared plus 6 squared, and so L squared 2 is equal to 18 squared plus 6 squared. 6 squared is 10, and then 18 squared you can quickly do for this. 18 times 18, 8 is 64, and then 8 plus 6 gives 14. Alright, so this gives 8, and then 1. So I have 4 3 4 2 and 3 3 to 4. L2 squared is equal to, when you add the both numbers, you have 360. Sorry. So L2 is equal to square root of 360. Okay. You know, when you add these two numbers, you find out that L2 is equal to 360 L2 squared, and then the next line follows. You take square roots and then you arrive to this point. So therefore, curved surface area will be equal to pi L2 minus pi L1. Okay, and which we have as, you can reduce this to be equal to root 36 root 10, which is equal to 6 root 10. Alright, so pi, we are not given pi, but arrow we have, the first arrow is let's check again. The first arrow there is 6 cm for the bigger pyramid, 6 cm, and L2 is 6 root 10 for the bigger pyramid 2, minus pi arrow for the smaller pyramid is 4 cm, and then L for the smaller pyramid, L1 is 4 root 10. 4 root 10. Okay. Alright, this follows that you have 6 times 6, you have 36 root 10, minus you have pi 4 times 4, you have 16 root 10. Okay, when you subtract this, you have pi 36 minus 16 gives you 20 root 10. Okay, so therefore the curved surface area is equal to, which is defined as subtracting the big cone from the front small cone, okay, which we've done, is equal to pi, or 20 pi root 10 centimeters squared. Alright, try to go across some other examples. These things are not really difficult, but with subsequent and constant practice, you will perfect on calculations of these kinds. Have a great day ahead. Thank you for being part of the class. Bye.